So for today, it is about graphing logs. Look at these two and tell me which one looks like exponential growth to you. Well, we read from left to right, so that one's going up like crazy, okay? This one's going up really slowly. All right, so if you understand the difference between a log, which is the one I'm going to put a squiggly blue line on, that's a log graph. And logarithmic growth is really slow. You know, like it isn't going up very fast. Whereas exponential growth, I'll use the squiggly red line for that. Exponential growth is like going up like crazy. All right, so which of these is more common? Well, it depends on the situation. Exponential growth is like something that's just going nuts. Like I would say healthcare costs. Like I've mentioned before to you guys, I used to pay $50 to add my family to my health insurance. And now I pay well over $1,000 to add my family to the health insurance. And so that's an example of like going through the roof, okay? This one is growing really slow. What's something that's growing really slow? Well, right now, human drivers are about here. Human drivers aren't getting better and better. Human drivers are just as good as they are. In fact, they may be getting worse because we're all so addicted to cell phones that it is really hard to like resist if a text comes in and you're driving and you're all of a sudden looking at your phone and then you're not looking at the road and then some little kid runs out and you could kill somebody. So I'm bringing it up because you can say, well, I wanted to see the text, and that's going to sound incredibly lame when you tell the mother of this little baby that you hit. Well, I got a text. So, you know, that is no excuse. You can't do that when you're driving. But people do it all the time. And so human drivers are at that level. And what's this? Well, this is slow growth of computers being drivers. And right now, I'd say they aren't better than humans. But there will come a time when the growth will go like this, and it'll just get more and more further apart, where humans are there and the computer is getting better and better. Not like incredibly fast, but like all of a sudden it's statistically significant. The computers will be better drivers than the humans. I don't think they are yet, but this is crossing like that. And that's logarithmic growth. It grows kind of slow. All right. So this is your log graph, the blue one. That's the one for today. So let's make sure you get how this is an inverse. Inverse means, get on this slide here, that you switch x and y around and then you solve. So right now it's solved for y. Do you get it says y equals? It's already solved for y. So if we swap those and we make this y and make this x, everybody do that. Then we have to solve for y again. That's what you do to make an inverse. Switch x and y around and solve for y. But how do I solve for this? That's logs. Log, and as soon as you write log, you'll be forced to think, okay, what's the next thing I got to write? And that's the base. Looking at this problem, what looks like the base to you? Well, there's only two things you could possibly pick, the 4 or the x. And I could understand making the mistake, but it's 4. 4 is the base. That's the base because it has an exponent on it. All right, so this is the base 4. And then you'll be forced to write another number. And then you got to remember that you go in the circle of logs. You never go in order. You jump back and forth. So it goes back over to there, which will be an x. And then it goes back over to here, which will be a y. And look, it's solved for y again. See what I mean? We started off solved for y. We swapped x and y. Now we're solved for y again. And what do we have? We've got a log. So it started off as an exponential. When I wanted to make its inverse, I got a log. Exponentials, logs, inverses of each other. All right, this one, imagine it's a test. Imagine they said, please find the inverse of this. Do the same process. Jack, what's step 1?
Replace the swap out the x and the y.
Yep, so this y becomes an x, and this x becomes a y. Addie, what's step 2? Yeah, you're going to do a log because you're trying to solve for y. Now, what is the base? Iris, what's the base here? Yep. And then do you go in order? Kili, tell me what to do.
And then you go in a circle, which would be x.
X is next. And then?
Y
Equals y. And now it's solved for y. And it's a log. Make sense? Okay. Now, what would be the graph of this? That's the other big thing for today, is what's the graph of this? Well, I've given you a thing that I've called your best friend in graphing, because we used it every single time. So if you don't know what that is, I'm really, really sad. I want you to try to figure out, I know you kind of know it sort of looks like that. I don't mean that. I mean, how do you get exact points? X, Y. All right, everybody take that XY chart and find a few numbers, and you may be like, I'm not sure what to put in. Well, try something. Put in something. And if you don't like it, like if I put in 3, I'll be like log base 7 of 3. I don't know what that is. Then I wouldn't pick 3. Pick stuff you know would work. All right, so name a number that you tried and it was pretty easy. It worked. 0. Everybody think through 0. 0 goes here. If you have a 0 there, you should know that that's not legal. In fact, that makes the asymptote. I'm going to pause for a second. So back to we put in 0, and whatever makes this 0 is the asymptote. That's important. Don't forget that one. Always try to make the inside 0, because that'll be where the asymptote is. Let me show you what it looks like on the graph. If x is 0, that'd be like here. Well, that's this dotted line right there. There is an asymptote there. All right, next, there's another number that would be smart to put in. Riker, give me a number.
7.
7 is a good call. And if you try putting it in, you'll see why. If you learned anything about logs, log base 7 of 7 is a nice, easy answer. What is it? Please tell me you know this. What's log base 7 of 7? It's 1. If these two match, then the answer's already there, and it's the exponent that's right there. Whatever exponent is there. Okay, cool. 7, 1. It's a point. And then there's one more that has to do with this dumb saying. If you won the argument, you get nothing. Yes, put in 1. If I put in 1 right there, you'll have a 1 in the argument spot. Do you remember me saying, if you won the argument, you get 0, you get nothing? That's like arguing with your friends over politics. Discussing is fine, but arguing, you're going to just lose a friend. You'll get nothing out of it. Log base 7 of 1 is 0. So then the answer is 1 comma 0. And is that enough? Yes. Yes, it is. I got 0 is the asymptote. That's key. 7, 1 means there's a dot like right there. And 1, 0 is a dot like right there. And if you know what they look like, you're just going to be like, oh, I know what they kind of look like. There. I've said before that a log is not a tree. If you'd sit, you're standing there looking at a tree, you'd be like, that's a log. No, that's different. They are related. But if that tree blows over, now you could say you have a giant log on your lawn. See how it looks like a tree that blew over? It's got roots too. But see, this is like the tree part that blew over in the wind. Now you can call it a log. It's dumb, but it works for me. So there's what logs look like. Let's do another graph or two, and then we'll be done. This one we're skipping. You know why? Because it's not a log. What's that? Exponential. Very good. So we're not doing that. How about this one? That's a log. What makes the asymptote? 0. Is it always 0? No, it's always what makes the inside be 0. Think for a second. If I did this, minus 2, do you get that that would move it 2 to the right? So another way to say it is, now what makes the inside 0? 2 would. And then that's where the asymptote would be then. It's whatever makes the inside part 0. So that is a great place to start. I agree. And I'm going to start with my list of points here, and I would include that as a point on my chart, even though I know it's not a point. 0 gives me the asymptote. Okay, George, give me another point that would work in here.
5.
5 is a good call, because log base 5 of 5 is 1. So 5, 1. Spencer, give me something else I could put in that always works. 0, give me the asymptote. I already got that one. It's the argument thing.
1.
Yes, you won the argument. If I put in a 1 for the argument, I get 0. 1 comma 0. Is that enough points? If as long as you have the asymptote and 2 points. For today, at least, that's enough. Now, what if they forced you to get one more point? Let me just show you what you could do. 5 works great. 25 also works great, but you get how 25 is going to be impossible to graph. It's going to, like, we're never going to give you a graph big enough to put 25 on there. So even though 25 would work, and it would be like 5 squared, you know, that would work, but it's too big for the graph. So here's a great way to do it. 1/5. Because that's like 5 to the negative 1. Do you see what I mean? And if you put that in, the answer is negative 1. So if you put in 1/5, that's 5 to the negative 1. And if you put in 1/5, you will get negative 1 as your y. 1/5, negative 1. Do you have to do that? Well, I'm just preparing you that if the test says you have to have 3 points, that's a good third point. It's always going to work. Make this into 1 over that. All right. So now, if I graph these, over 5 up 1, dot right there, 1, 0, dot right there, 1/5, negative 1, dot right there, and then here's my log graph. And the asymptote is at 0. Now, let's answer these questions because this is going to be on every problem. What's the domain? Does this thing go forever in both directions? No, it does not. It goes from 0 to infinity, and it does not touch 0, and you can't touch infinity. Range. What's the lowest this thing goes? Infinity. What's the highest? Wait a minute, we're doing range. What's the highest that this thing will go? Infinity also. And I'm fine with you writing INF or the sideways 8. And then LEB, left end behavior. Don't worry, on the test I would tell you what that is, because that's not a math word. That's just the teacher not wanting to have to write out left end behavior. And so what is this doing on the left end? You write lim of f of x, x approaching. Now you got to think. On the left side of this thing, which is right here, that's the left side, x is going towards, does it get to go forever towards negative infinity? No. The x is going closer and closer but never touches 0. Okay, so on the left, the x is approaching 0. X is getting closer and closer to 0, but never touches it, so it approaches 0. And then this is about the y value when you get there. Generally, where is this thing going y-wise? It's going down, 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 down. It'll keep going forever. So y, in terms of y, it's going towards negative infinity. All right, yes?
Isn't it when it's like approaching the total, isn't it like we have to say it's coming from the
Very nice. I was just about to add that, and I'm thrilled that you remembered it. There's one more little detail. When you're approaching a vertical asymptote, you could come from this side or you could come from this side. And we are coming from the positives. You have to put a little tiny plus right there. That's the new thing on limits for this unit that comes up. that didn't come up last time we did limits. Because last time we only did like limits that were on the way right and way left, and the asymptotes were horizontal. So on this kind of asymptote, you got to say, I'm approaching x is 0, yeah, but which way am I approaching it from? Am I coming from this side or am I coming from this side? And if I was coming from the positive numbers, this is where the positives live, you put a little plus right there. All right, the right end behavior. Everybody right limb. F of x. X approaches. You will write that on every single limit from now till the end of calculus. Let's get used to that. What about the right end? What's it doing on the right end? Well, is it still rising? Is it still going to the right? So you should be able to put in the two things for that. X is going way to the right. I guess that's positive infinity. And it's still rising. I know it's not rising fast, but it is rising. It's going up. Slowly, but still it's going up to infinity. That was doing the right end of the graph here, where the x was generally going towards infinity and the y was also going towards infinity. Okay, I feel like you're pretty much ready, except you need to do 1. That's an exponential, so we're not doing that. If we did this one, though, right underneath that, you see ln x? That'd be a really good review of the, what about the ones that don't have a base? The ones that say log and don't have a base is 10. So if it said this, and you'd go, oh, base 10 then. But this kind is base e. So if I were you, the first thing I would do is rewrite my problem. I'd give you permission, whenever you see ln, you should write log base e. And it makes your life a lot easier. Okay, server, I wrote log base e, but now what? Well, you find points. You need to figure out what makes this 0, because that'll be the asymptote. And then you got to figure out smart things to put in, like a 1, because then you won the argument. And what last one? What should we put in? E, very good. If you put in an E, then you got the same base, and so the answer will be 1. And if you're like, how am I supposed to graph E? Do you remember it's just a little less than 3? So when you graph E, go to where 3 would be, but a little less. It's 2.7 about. Okay, so take a second. And this is just almost exactly the same as log base 3 of x. It's just a little less than a third. Take a second, figure out what the asymptote is, get some more points, graph it. I know it kind of looks like that, but I need exact points. Figure out this domain, figure out its range. Figure out the left end, the right end. If you can answer that, you totally understand this, and I can give you a mammoth amount of time for work. But I'm going to pause, try to do this really well. Talk to the kid next to you. If you get stuck, ask me. Okay. Need some specific points. Garrett, what'd you get for some points on x, like x comma y?
I did 0 for the asymptote.
0 makes the inside 0, so it's the asymptote. I agree. What's next?
I did E, which would be
Yep,
1.
because if you put an E right here, then you have log base E of E, which is 1. Good, keep going.
And then I did 0, which would be 1.
Put it,
Would be 0.
wait a minute, x should be what?
That should be at least 1.
X is 1, good. So then you got a 1 in the argument spot, and you won the argument, you get nothing. Okay, good. And what's one more that I said, if they make you have 3 points? Yes, if you make this 1 over whatever the base is. If you make it 1 over E, that means it's E to the negative 1. And that means you get negative 1. So 1 over E, you might be like, but I don't know what 1 over E is. It's pretty much 1 over 3. No teacher is going to be able to tell the difference between 1 over 3 and 1 over E if you grade it, because like E is pretty much 3. So it's 1 over 2.7 instead of 1 over 3. It's pretty much the same spot. And when I do that, I would get -1. Now, I don't have to have that right now. I'm fine with 2 points today, but just trying to warn you, the test might require 3 points. All right, so then if I go over E, what the heck is that? That's about 3, a little less than 3. I go up 1. So notice me going over a little less than 3 and up 1. Okay, and then 0 is the asymptote, so I'm going to use a red line so it can kind of stand out on top of that y-axis. And then I have 1 comma 0. That's right there. So if I use this, that's all I'd have to have. And I know what they look like. They're like a tree blown over and in the wind. Log. Make sense? Now, let's answer these questions. Addie, what's the domain? 0 to infinity. Is there a bracket on the 0 or a parenthesis? Parenthesis. Range. Alex K, what's the range of this thing? You are correct. And the left end behavior hint, it's a limit. Volunteer? Yes. Yeah. On the left end, which way are we headed towards? The X is headed towards
The X is headed towards
0.
0.
From the positive side or the negative side?
From the positive
From the positive side. Okay, keep going.
And then the X goes
Yeah, this is y. Goes towards negative infinity. You are correct. Okay, now how about the right end? That's over here. Well, what's X doing? It's going this way. It's going towards lim f of X. X is heading towards infinity. And what about the Y? The Y value is at the end. Upwise, it's going up. It's still going up, 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 up. There's no limit on it, so infinity. I know that's the weirdest one because it doesn't feel like it's headed towards infinity, but then what's it headed towards? It's going up. If you go far enough, it'll go eventually towards infinity, unless there's an asymptote. No, there isn't. There's asymptotes only up and down. It's a vertical asymptote back here on the y-axis. So that goes towards infinity. And that is enough. You now have 4 questions, just 4. And the worksheet is already there. And it says, is it 4 or 5? It's listed in the title of the
It
worksheet.
says 2, 6, 7, and 9.
2, 6, 7, 9. That is 4 questions. They have like multiple parts though. You know, they want them to domain in the range, whatever. So you should be able to finish in class though. And you should be able to finish yesterday's. Some of you got it done fantastic. I know who you are. Some of you didn't. Please go ahead and do that. And then that's all I got for you for today.